My name is Oktay. Welcome to the second part of the images from the Hubble Space Telescope. The telescope was named after Edwin Hubble. He gave us an idea of the real structure of the universe. He discovered that the Andromeda Galaxy was not a nebula within the Milky Way, but another galaxy. And his measurements of the redshift of the galaxies gave us the idea of the expanding galaxy universe. The galaxies further away have a higher redshift and move faster away from us than the nearby galaxy. The Hubble Space Telescope was launched in April 24th in 1990 in the Space Shuttle Discovery to Earth's orbit. This is a picture of Saturn at a distance of 9.5 AU. 1 AU is a Earth's sun distance, 150 million kilometers. Saturn is the Roman god of wealth and agriculture and the father of Jupiter. The equatorial diameter is 120,536 kilometers and the rotation period is 10.5 hours. Saturn orbits the Sun every 29.5 years. Its density is very low at just 0.687 gram per cubic centimeter. Saturn is still 95 times has 95 times the mass of Earth. And today we know it has 83 moons, the biggest of which is the moon Titan. Titan is a unique moon. It has its own atmosphere and a cycle of methane, like the cycle of water and Earth. At the left is a picture of Luhman 16. It is a pair of brown dwarfs at a distance of 6.5 light years. So this is in our stellar neighborhood. At the right there are more objects like Luhman 16. It is named after Kevin Luhman, who discovered these two brown dwarfs in 2013. They orbit each other at a distance of 3.5 AU. The bigger one is a L-type brown dwarf with 34 Jupiter masses, and the other one is the P-type brown dwarf with 29 Jupiter masses, and they orbit each other every 27 years. This is a picture of a stellar neighborhood. This is Luhman 16, A and B. Brown dwarfs have a typical mass of 13 to 80 Jupiter masses. Their core is not hot enough to make a hydrogen fusion, but they are able to merge deuterium nuclei. And the bigger brown dwarfs with higher mass than 65 Jupiter masses can also make a lithium fusion. Among the brown dwarfs, there are 4 subtypes, M, L, T, and Y. And there are several more brown dwarfs in our stellar neighborhood. This is artist's conception of how the brown dwarf Luhman 16b could look like. This is a T-type brown dwarf. K2-18 is a red dwarf at 124 light years distance. It has half the Sun's mass and 2 planets which are in the category super-Earth. The inner planet K2-18c has 5.6 Earth masses, orbits every 9 days, and the outer planet K2-18b has 8.6 Earth masses, orbits every 33 days. The outer planet K2-18b is very interesting because it's near the habitable zone of this red dwarf. This is how it could look like. It's a sub-Neptune planet. The calculated average temperature is -8 degrees Celsius because it depends on the composition of the atmosphere. And the Spitzer and the Hubble Space Telescope both detected water in the atmosphere. This is the Ring Nebula, NGC 6720. At a distance of 2,567 light years. It was discovered in 1779. It's a planetary nebula with a diameter of 2.6 light years. Its nucleus is an object 60% of Sun's mass, and the surface temperature is 125,000 degrees Celsius. The radiation of this object makes this nebula glow. And we are witnessing a formation of a white dwarf. The Sun in the future will also become a white dwarf. This is the Eskimo Nebula NGC 2392 at 6,500 light-years distance. It was discovered in 1787. Has a diameter of 0.68 light-years. This is again a planetary nebula. Its age about 10,000 years. And we are again witnessing a dying star in the center. This is Trumpler 14. It's an open cluster in the Carina Nebula at 8,980 light-years. Its diameter is 6 light-years. It contains 2,000 stars with a total mass of 4,300 solar masses. There's a dark patch called a Bock globule. It's a gas and dust nebula. This is the Whirlpool Galaxy at the left, NGC 595. At the right, NGC 5194. At a distance of 31 million light-years. Its diameter is 76,900 light-years, so it's about 3/4 of the size of the Milky Way. And its mass is 10% of the mass of the Milky Way. And this early phase of a merger of two galaxies. This is NGC 2976. It's a dwarf galaxy at 11.6 million light-years, so it's a diameter of 20,000 light-years. And at the outer disk, we can see a star formation. This is the Antennae Galaxy. It's an interacting galaxy pair with NGC 4038 at the top and NGC 4039 at the bottom at a distance of 45 million light-years. Contains many globular clusters with massive star formation. The composite image of Hubble and ALMA. ALMA is the Atacama Large Millimeter Array in Chile. And the blue shows you the new stars. And the red, pink, and yellow is the color of the dense clouds. This is Westerlund 2. It's a cluster of young stars in the Milky Way. Its age is about 1 to 2 million years. It is at a distance of 20,000 light-years and contains over 30 massive O stars. The O stars are the biggest stars in the universe. And Westerlund 2 is named after Bengt Westerlund, who discovered this cluster in the 1960s. This is NGC 6388. It's a globular cluster discovered by James Dunlop in 1826. It is at a distance of 32,300 light-years. And it has a total mass of 2.2 solar masses. This is a famous astronomical object. It's the Sombrero Galaxy Messier 104, NGC 4594. It's at a distance of 30 million light-years. It has about half the size of the Milky Way with a diameter of 49,000 light-years. It was discovered in 1781 by Pierre Méchain. It is a big bulge and a supermassive black hole with a billion solar masses. The infrared picture of Hubble and Spitzer of the Sombrero Galaxy. This galaxy is a lenticular galaxy with 2,000 globular clusters. A lenticular galaxy is intermediate between a spiral galaxy and an elliptical galaxy. This is a spiral galaxy which is about to become an elliptical galaxy. This is our 273. It's an interacting galaxy pair. At the top is UGC 1810, bottom UGC 1813. It's at a distance of 300 million light-years. The bigger galaxy at the top has 5 times the mass of the smaller at the bottom. And you can see the distorted spiral arms, especially this one. And the theory is that this comes from a previous collision which was off-center. So if you have one big and one small galaxy, during the merger, the bigger galaxy usually can maintain its structure, with one exception. That's if it hit the core. This is NGC 3521. It's a bubble galaxy with a flocculent spiral galaxy. It's at 35 million light-years distance. It's 80 billion solar masses, which is about less than 10% of Milky Way's mass. This is NGC 6872. It's Condor Galaxy. It's a spiral bar galaxy. And this galaxy has a companion IC 4971, which is again a lenticular galaxy, which is at the top. It's located at a distance of 212 million light years. It has a diameter of 522,000 light years, which means 5 times the Milky Way's diameter. And we can see star formation in its arms. That is triggered by this merger of these two galaxies. There's another merging spiral galaxy pair, NGC 2623. This time it is at the advanced stage. You can see the tidal tails. This galaxy pair is located at a distance of 155 million light years. Its diameter is 50,000 light years. And we can again see the formation of new stars. This NGC 4911, it's a spiral galaxy interacting with its companion galaxy at a distance of 320 million light years. It is gas and dust rich, and again this interaction starts a star formation. This is again the picture of Hubble Ultra Deep Field in 3D. This is a beautiful picture. It shows you this distribution of the galaxies in the universe, the bigger filament structure of the universe, and one important factor in this structure is dark matter, which makes 23% of the universe. 73% is dark energy, which works against gravity and causes the expansion of the universe. And the normal bright matter makes only just 4%. So the dark matter is important for the filament structure of the galaxies and for the galaxy itself. It gives without dark matter, the stars would just fly away. This is a very beautiful picture of the Laniakea Supercluster. Laniakea is a Hawaiian word for immense heaven. It was discovered in 2014. We are here at the red spot. This is a structure of 100,000 galaxies which are distributed over 520 million light years. The Laniakea Supercluster has a mass of 10 to the 17 solar masses, or 100,000 Milky Way masses. It's a very beautiful and inspiring picture, and in my opinion, this is also a humbling picture. That was today's video about Hubble Space Telescope images. Thank you for watching. Have a nice day. Bye-bye.